a new chapter called as brute force and exhaustive search. This is chapter number 3. First, first one is the definition. What is the meaning of brute force technique actually? Brute force is a straightforward approach to solving a problem, usually directly based on the problem statement and definition of the concept involved. In another way, the brute force technique can be described as just do it. Just do it. What is the meaning here is, when any problem is there is a one straightforward solution for that problem is there. That is called as brute force technique. In that problem itself, we can easily find some solutions. That type of solution is actually called as brute force technique. For example, now if I want to identify what is the result of a raised to n. Now if you simply think, if a is the positive number and n is a non-negative number, how to solve such problems? In a straightforward method, that is just do it method, we can just multiply this a n number of times. When you multiply this a n number of times, it is nothing but a raised to n. So we have to apply such algorithms where you have to multiply a n times. For example, if I want to calculate a raised to n, you have to multiply like this way up to n times. Now see this example. If I want to calculate what is the meaning of 2 raised to 5, how to calculate this formula? It's nothing but 2 raised to 2, and again you have to multiply it with 2, again you have to multiply it with 2, then 5 times. You have to multiply 5 times. It's nothing but 2 raised to 5. Now you got 4 here, 4 multiplied again, you got 8 here, you multiply it again by 2, it's nothing but 16, and when you multiply it you got a 32. 2 raised to 5 is nothing but it's a 32. Multiply this one, then multiply with 4, then multiply with 8, then multiply with 16, you got 32. This is the simple way of thinking to solve this problem. So it is called as a brute force technique. Most of the times these brute force techniques are not efficient one. Maybe sometimes it's efficient one, means consume less power, less execution time, less memory space. But when you found most of the times this brute force technique is a non-efficient algorithms. It consumes more processing power, more memory, like that way. Still we are using the brute force technique for solving some algorithms. There may be some reason is there. There is only one solution. We can solve that problem using brute force. Okay, in such situations occurs. In last class you already solved most of the algorithms using this brute force technique, such as the GCD algorithm, that is Euclid algorithm, or you are finding the largest element in the array, or finding the duplicate element in the array, or matrix multiplication. All these are actually solved using some straightforward technique or just do it technique called as brute force techniques. Next slide we studied some of the more points about this brute force techniques. Now see in which situations we are using brute force techniques. Now brute force technique can be applied It seems to be the only general approach for which it is more difficult to point out problems it cannot tackle. In some situation, there is no any solution to solve some problems. We can only solve it using brute force technique. In that case, we are using brute force technique. In second one, for some important problems like sorting, searching, metric multiplication, string matching, the brute force approach yields reasonable algorithm of at least some practical value with no limitation on instance size. That means if sometimes the input size increases, as the input size increases, some of the algorithms won't work, some of the techniques won't work. But more brute force techniques or brute force approach will solve that problem whenever the instance size is large. Whenever the input size is large, still that brute force technique works most of the times. Third one is called as the expense of designing a more efficient algorithm may be unjustifiable if only few instances of problems need to be solved, and brute force algorithms can solve these instances with acceptable speed. Okay, here the meaning here is, if you are having small number of input values and you are applying a very expensive design, means you are applying some other techniques which will take some of the more complex applications, you are getting a difficult in solving that problem. So use a simple technique called as brute force technique. Whenever you have a small or input size, a simple input size. The next one is called as brute force algorithm can still be useful for solving small size instances of a problem. As I told, if the input size is very small, better to use brute force technique, because brute force algorithms are very simple one, easy one. Brute force algorithms can serve as important theoretical and educational purpose as a yardstick with which to judge more efficient alternatives for solving a problem. We are solving many problems by using brute force technique. If you see, many problems can be solved only by using brute force techniques. If you design any other new techniques, you solve the same problem by using some other techniques, then you can use this brute force technique algorithm as a measurement stick or yardstick. You can compare which one is better. To measure that one, we need some brute force technique algorithms. In a brute force, we find all the different possible solutions and try to identify which one is the best solution for that problem. So it is called as a brute force technique. In brute force, many solutions are there. We are trying to identify which one is the best solution among them.